This is Unit 4 Case Connections. My name is Michelle Hughes. Today is November 16th, 2020. All right, let's get started. So the first case is about distinguishing between urea cycle and beta oxidation. And before I get into the case connection, I wanted to review the urea cycle and beta oxidation separately. So the urea cycle can occur in both the fed and the fasted state, and its function is to remove excess nitrogen in the form of urea to be excreted in the urine. So here we have, at the beginning, we've got ammonia and carbon dioxide coming into the mitochondrial membrane, and then it's being shuttled down via CPS1, and that is going to form carbamyl phosphate. And the the urea cycle, you see here it kind of overlaps in the mitochondria and the cytosol. So it's occurring in both places. And it goes through a series of reactions here all around until we get to arginase, which is going to release the ammonia into urea, and then the urea will be excreted, and the ornithine continues the cycle. And the main regulator of this pathway is the carbamyl phosphate synthetase 1, and it requires N-acetylglutamate or NAGS and ATP to be able to function. So here we have beta oxidation, and beta oxidation is the process of shuttling free fatty acids to acyl-CoA, and then the acyl-CoA is shuttled into the outer membrane through CPT1, and then it is going to go to carnitine, acylcarnitine, and then it's going to be pumped further into the matrix where CPT2 and carnitine acylcarnitine translocase work to break down these substances, and the acyl-CoA is eventually moved into the cycle of beta oxidation. And beta oxidation here is the dehydrogenase, hydrolase, dehydrogenase, and thiolase reactions. And the products, which are the most important, are NADH, FADH2, and acetyl-CoA. And acetyl-CoA has two fates. It can either be used as a substrate for ketogenesis, or it can be shuttled into the TCA cycle to produce more energy. So the first case here, we have a newborn girl, and within 24 hours, she develops the symptoms lethargy, hypothermia, and apnea. And the prompt is asking us which diagnostic test would be best to distinguish between a urea cycle disorder and a disorder in beta oxidation. The four options are blood glucose, urinary acids, serum fatty acids, and plasma glutamine. So the blood glucose test would be useful for a beta oxidation disorder, but not urinary acids. Urinary acids would be useful to determine a urea cycle deficiency, but not beta oxidation. And then the serum fatty acids are used for fatty acid synthesis in the fed state. So, glucagon and epinephrine are going to inhibit, and insulin and will activate this cycle. So that leaves us with the plasma glutamine option, and that's because you do see overlap between beta oxidation and the urea cycle with the plasma glutamine. And I'll show you that on the next slide. So here we have some pathways, and most notably the transamination pathway on the bottom here. So glutamate can be synthesized to glutamine, back to glutamate via glutaminase, and then glutamate. And this releases an ammonia, which is linked to the urea cycle and can be expelled as urea in the urine. And alpha-ketoglutarate, as seen down here in the transamination reaction, is an intermediate of the TCA cycle. And the TCA cycle, if you remember, is it does require acetyl-CoA, and which is the main product of beta oxidation. So it can be either used for the TCA cycle or ketogenesis. And these are the lab results that were presented. So the blood ammonia level is elevated, urine orotic acid level is elevated, and a citrulline level is slightly below normal levels. And so this led me to believe that there is a urea cycle disorder, and deficiency in OTC is the most likely to be impaired because of the elevated ammonia and orotic acid. And the citrulline is on the low end, which leads me to believe that CPS1 is not impaired because the body is still producing citrulline here. So ornithine carbamyl transferase is the enzyme that I'm thinking is the impaired enzyme. And that's because it's accumulating orotic acid, and it's also accumulating ammonia instead of expelling it. And CPS1 is not affected because it's still functioning to get to the carbamyl phosphate, and it's still producing low levels of citrulline that way. But OCT is likely the culprit for the patient's symptoms. So the next case, case 3, the patient complains of pain in the right toe, and he's unable to bear weight on it. And based on the physical exam, he's diagnosed with gout, and our job is to determine the best explanation for his particular presentation of gout. And over on the right side in this table, you see his blood lab results. So the plasma urate is elevated, but the urinary acid and urinary uric acid is within a normal range. And we have overproduction of purines, decreased purine salvage, and decreased urinary excretion of uric acid as our choices. So to go over purine synthesis first, ribose 5-phosphate is transferred to PRPP, which then is eventually turned into IMP, inosine monophosphate. And IMP has two fates. It can either go down here through IMP dehydrogenase, eventually to GMP, GDP, and GTP, or at the top here, it can be it can lead to AMP, ADP, and ATP. So another piece of information we were given is that the patient switches diet from soda to regular, diet soda to regular, and this will lead to more fructose accumulating in the body, which increases purine synthesis and ultimately uric acid. And decreased purine salvage is not the correct answer, because if purine salvage was decreased, that would lead to high levels of uric acid in the urine, which was not seen in the lab results. And decreased urinary excretion of uric acid is usually caused by excess alcohol consumption, and therefore we can eliminate this answer based on the lack of information. So the best answer would be because the patient switched from diet to regular soda and fructose does stimulate purine synthesis, that we can draw the conclusion that purine synthesis is kicked into high gear, and that's the cause of the patient's gout. So the best option for this patient would be to eliminate regular soda from his diet, and that way the purine synthesis wouldn't be overproducing purines, and likely the gout would resolve within a week or so. And that's all I have, so thank you.